Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 5, Lesson 8, Session 1, Measurement Conversion Between Systems. Okay, so it starts out, be curious, what do you notice? What do you wonder? And well, I noticed that there's three different cities listed on a sign next to a road telling us the distance to these places from where this point is. And Pacific Valley is 5 miles, but that's equal to 8 kilometers, and so on and so on. So miles, these are equal distances. So that tells me right here that miles are longer than kilometers. Okay. So I wonder why the whole world uses the metric system besides us. Anyhow, let's continue. Speed limit. Evelyn is visiting family in Canada. This picture is not Canada. That is probably Europe or somewhere like that. They use a white circle with a red outline. She sees a sign shown on the highway and wonders whether the speed limit shown is faster or slower than 100 miles per hour. So is 100 kilometers per hour faster or slower than 100 miles per hour? That's the question. How can Evelyn determine which is faster? The 100 kilometers per hour or the 100 miles per hour? Well, Evelyn could make a conversion if she knew the equivalent values. So what quantities are in the problem? Okay, well, we have 100 kilometers and we have the 100 miles. Those are the two quantities that are in this. So the quantities are both 100, but in different units of measure. Okay, so this question is asking, what do the quantities miles per hour, okay, and this is usually written mph, and kilometers per hour, kph, okay? But if I go back, look at how they did this. Km for kilometers and a line meaning per, okay? So actually it's not kph, it's km per h, or kmph. Instead of miles per hour, it's miles per hour. Okay, so what do the quantities represent? Miles per hour and kilometers per hour. How can we, oh, by the way, what do those quantities represent? Well, if you're trying to figure out distance and how long it takes you to get there, well, that is speed. Okay, that's how fast you're going. The length of time it takes you to get a certain distance is your speed. So how can we relate miles per hour and kilometers per hour? Okay, so, well, we can look up a conversion and we could write it this way. We could say X number of kilometers, okay, over Y number of miles. That's one way where X and Y are not equal, obviously. Or I could have put X number of miles in the numerator over Y number of times the number of kilometers. Okay. So those are the two ways we can relate them. Kilometers per mile or miles per kilometer. Okay, so on this page, they're saying kilometers and miles are both measures of distance. We can compare kilometers and miles. 1 kilometer is about 0.6 miles. Okay, so they're rounding to the nearest tenth. A more accurate is 0.62 miles because the faster you go, the more you're going to be off if you're going to round to the 10th. But anyhow, they rounded to the 10th. 0.6 miles is approximately 1 mile. It says, how can you represent this relationship as a ratio of kilometers? 2 miles. Okay. So, well, you just look here. Kilometers is 1. So it'd be 1 km to 0.6 mi. All right. But if I want 1 mile, how can you represent as a ratio of kilometers to miles? So there it is. Kilometers to miles. 1 kilometer is 0.6 miles approximately. So it's 1 to 0.6. I did it as a fraction. You can also use it as with a colon. And it says, how can you use this relationship to determine which speed is faster? Okay. Well, if you look at this, if 1 mile is more than a kilometer, and if we are going 100 miles an hour, then we're going to be going more than 0.6 miles per hour times 100. So it's this distance further. So 1 mile is this area here distance more than 1 kilometer. So if I had 100 of these blue squares and 100 of these larger rectangles here, obviously the miles is faster. So 100 miles per hour is greater than 100 kilometers per hour. So how can you use the ratio of kilometers to miles to compare the distance traveled in 1 hour? Okay, so there's 2 ways we can do this. Kilometers to miles. So we want to go in this order, and that equals 1 over 0.6. Okay, so if we're going 100 miles per hour, then we want to compare that to this being 100. And we have to find out how many kilometers that is. So basically what you're doing is, what do I multiply 0.6 by to get 100, or 0.6, 100 divided by 0.6? And in order to multiply that, you just move the decimal over. 6 goes into 10 once, 6, subtract, get 40. 6 times 6 is 36, subtract, get 40. 6 times 6 is 36, and we're going to repeat this 40 over and over. So it was 1.6 repeating kilometers per hour, or this was 100 miles. So I had to multiply 0.6. Is that right? No, of course it's not. I have to multiply 0.6 times what to get 100? It's not 1.6. It's 166.6. Okay, so I move the decimal over 1, and it was 100, so now it's 1,000. So this should have been here. So when I multiplied by 1 and then by 4, I'm sorry, 6, right here, it's 166. The decimal was here, 0.6 repeating. So 100 miles is 166.6 kilometers. And that's repeating. So basically all we're doing is you could either think of it as finding out what to multiply to get this, or we could have cross multiplied. So if we called this x, 0.6x equals 100 and then divide. So that's, and you're going to get the same answer. So how can you complete the table of equivalent ratios to compare the miles to 10 kilometers to 100 kilometers? Well, kilometers going from 1 to 10 was a multiple of 10. We multiplied by 10. So if I multiply 0.6 times 10, I'm going to get 6. If I multiply 10 times 10, I'm going to get 100. So I'm multiplying by 10 again. So 6 times 10 is 60. Okay? So 100 kilometers per hour is approximately 60 miles per hour using this decimal approximation. Okay? So how does 100 kilometers per hour relate to miles per hour? Well, 100 kilometers per hour is equivalent to 60 miles per hour. So 100 miles per hour is faster because if you traveled 100 miles in 1 hour, you will travel farther than if you traveled 100 kilometers in 1 hour. Okay. So it'd be 100 of these. If we multiply by 100, then if this one square is equal to 60, then 100 would be way out here, and 100 kilometers is here. So Evelyn is visiting family in Canada. She sees the sign. Okay, this is just a repeat. How can Evelyn determine which is faster, 100 kilometers per hour or 100 miles per hour? And it says, what level of precision does this solution require? Okay. So we have to be precise as to what we're going to use for our units. Okay. So they use 0.6. That is not entirely accurate because if you Google it, 1 mile is approximately 0.62. I'm sorry, 1 kilometer. 1 kilometer, 1 km is approximately 0.62, and then it's 0 something, something, something. Okay, there's a few more numbers out there, but usually this is a better approximation because when you're driving, if you use 0.6, you'd only be going 60 when the speed limit's actually 62. So the ratio of kilometers to miles is about 1.61 to 1. Why is the ratio of kilometers to miles different than the ratio from miles to kilometers? Well, if I do miles to kilometers, then I would have 1 kilometer is 0.6. Using their approximation is 0.6 miles per kilometer. Okay. However, if I switch it and I do kilometers per mile, then that's going to become 1 over 0.6. So if I divide that, that means division. I would ask myself, what is 0.6 divided by 1? Okay. And well, it's obviously 0.6, right? So this is equivalent to 0.6, but then this one, 0.6, and if I move the decimal over to 6, now I'm moving the decimal over from 1. I'm dividing 1 by 0.6. I'm going to get, how many times does 6 go into 10? It's 1. 1 times 6 is 6. And now I've already done this. So that's how we got our 1.6 repeating. So one of them is 0.6 divided by 1. Anything divided by 1 is itself. And the other one is 1 divided by 0.6. Okay. And that's why we get 1.6 repeating, which is here, instead of 0.6. So one's a reciprocal of the other or an inverse. So part B says 1 meter is about the same length as 1 yard. Knowing that 1 meter equals 100 centimeters. Okay, so I'm going to write this. 1 meter equals 100 centimeters because the word centi means 100. That's why we call our pennies cents. There's 100 cents in a dollar. And 1 yard equals 36 inches. So if I put 1 yard equals 36 inches, what can you conclude about the ratio of centimeters to inches? Okay. So 100 centimeters. So if 1 meter is to 1 yard, as 100 centimeters is to 36 inches. So that's what we could put here. So 100 centimeters is to 36 inches. Okay. Actually, I just wrote it there, so I don't need to write it again. So it says, what can you conclude about the ratio of centimeters to inches? Okay. Well, 100, let's just use the calculator here. 100 divided by 36, just to save time. 100 divided by 36 is 2.7 repeating. Okay, or actually that'd probably be about 2.8. 2.7 repeating rounds to 2.8 centimeters per inch. Okay, so there's about 2.8 centimeters per inch. All right, so that brings us to the end of session 3. Thanks for watching and have a great day. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 5, Lesson 8, Session 2, Measurement Conversion Between Systems. So Terrence is helping at a veterinarian's office. A customer needs flea treatment for her dog that weighs 31 pounds. The flea treatment comes in 4 packages shown. This one is up to 4 kilograms. This one's 4 to 10 kilos. This is 10 to 25 kilos, and this is 25 kilos. What package should Terrence give the customer? What is unique about the units in the problem? Well, the units in the packaging are in kilograms. The way she weighed her dog was in pounds. So we need to do a conversion. Okay. So how can we compare 31 pounds to the units on the packages? We can convert. Okay. So 1 pound is approximately 0.45 kilograms. So once we know this, and we represent this as a ratio of pounds to kilograms, it'd be 1 to 0.45, okay? Or 1 over 0.45. And if you want unit of measure, that would be 1 pound, that'd be 1 kilogram, okay? So the ratio of pounds to kilograms is 1 to 0.45. How can you use the ratio to determine which medicine package a 31-pound dog needs? Well, we could use the fraction format of this and then multiply. So let's do that first before we go to that table. So if we write this as 1 pound is 0.45 kilograms, and we have 31 pounds. Okay. What we have to do is we have to move this to the denominator and put an X up here. Okay. So in order to do this, we want to cross multiply and or actually cancel pounds. A pound divided by a pound is a pound, and 1 times X is X over, and it's 0.45 kg. Actually, do I want to use an X if I do it this way? Probably not. So let me just erase this X. Okay. So 1 pound is to 0.45 kilograms as how many kilograms is 31 pounds? That's what we're trying to find. So let me redo this instead of crossing out. So in other words, if I go to 31 pounds, which is what our dog weighed or her dog weighed, 1 pound to 31, I multiplied by 31. So I could multiply this by 31 as well to get an even distribution. And if I take 0.45 times 31, okay, I'm going to get 5 times 1 is 5, 1 times 4 is 4, 1 times 0 is 0, bring it 0, 3 times 5 is 15, 3 times 4 is 12, plus that carried 1 is 13, and I don't want that decimal there yet. I'm going to add these, and I get 13,1395, and there are 2 decimal places. So that is 13.95 kilograms to be exact. Okay, so if I now go back to the problem, 13.95 kilograms would be between 10 and 25. So we're going to give her pet, her dog, this size here. Okay, dog's 10 to 25 kilograms. Another way we could do it is create a table of equivalent ratios. And we're going to do multiples of 10. So if I made this 10 pounds, 1 times 10 is 10, so I'm multiplying by 10. If I multiply this by 10, it moves a decimal one place to 4.5. If I multiply, and then if I do another 10, well, that's times 2. This is going to be 9. If I multiply this by, if I increase that by 10, okay, then these are being increased at even amounts, 10, 20, 30, 40, and this would be times 10, 9, 13.5, and 18 for 40. Okay, so this was multiplied by 20. So that's multiplied by 20. This one's multiplied by 30, and then this one's multiplied by 30. Okay, and multiply by 40, multiply by 40. How can you complete the table to determine how much 31 pounds is in kilograms? We just did. And 31 pounds, then we look at here. This is just an approximation. There's 30 pounds. So we're at 13.5. So 1 more pound would be a little bit more weight. And what did we get? Where did it go? 13.95. So that 13.5 went to 13.95. So we increased 0.45 for 1 pound. Interesting. So I can use multiples of 10 to complete the table, which we did. 30 pounds is about 13.5 kilograms. So it would be this flea treatment here. Okay. So what units of measure are needed to be precise? Well, we needed kilograms and we needed pounds. Pounds per kilogram. What would you expect the ratio of kilograms to pounds to be? Okay, so now it's kilograms to pounds. All right. So back here it said pounds to kilograms, right? Somewhere. Yeah, the ratio of pounds to kilograms is 1 to 0.45. So let's go back to here. So pounds to kilograms was 1 to 0.45. So kilograms to pounds, what we want to know is how many pounds are in 1 kilogram. So I would take 1 and divide it by 0.45. So 0.45 and 1. 1 divided by, that's what this means. And to divide by a decimal, we move 2 places to the right, and therefore we do that as well. So we're going to end up with 45 instead of 4.5. And we're going into 100 instead of 1. 45 will go into 45 will not go into 100 or 10. It'll go into 100 one time, or 2 times. I'm sorry, 2 times. So 45 times 2 is 90. Subtract and get 10. Put a decimal, bring it down, decimal. 45 goes into 100 2 times. Well, it's going to keep repeating. Okay, so it's going to be approximately 2.2 pounds. So I'm going to put 1 over 2.2 repeating. Okay, knowing that kilograms are a greater unit than pounds, how can you explain why grams are smaller unit than ounces? Well, kilogram means 1,000 grams. So 1 kilogram equals 1,000 grams. Okay, 1 pound is equal to 16 ounces. So if I divide pounds by 16, I get 1 ounce. So if I take 1 pound, divide it by 16 ounces, okay? 1 pound divided by 16 ounces is going to equal, let me think about this a second. No, I don't want to do that. 1 pound is 16 ounces. 1 kilogram is 1,000 grams. How can we explain why grams are a smaller unit than ounces? Well, there are 2.2 pounds in a kilogram, right? So if I take 2.2 and multiply it by 16, that's what I wanted to do. Multiply that by 16. All right. There are 2.2 pounds in 1 kilogram, 16 ounces in a pound. 2.2 times 16 will tell us how many ounces are in a kilogram. So 6 times 2 is 12, carry the 1. 6 times 2 is 12, plus 1 is 13, 0. 1 times 2 is 2, 1 times 2 is 2, and we get 35.2 ounces per kilogram. Okay, but there's 1,000 grams per kilogram. So if it takes 1,000 grams to make a kilogram and it only takes 35.2 ounces to make a kilogram, then obviously grams are smaller. Okay, hopefully that makes sense to you. Summarize, measurement, conversion between systems. You can use ratio reasoning to convert measurements from one unit to another between measurement systems. The relationship between two corresponding units in different measurement systems is a ratio relationship. The ratios are often approximations. The table shows common conversion factors for units of length, capacity, and mass or weight. So if you notice, these are approximation symbols. They're not exact because they rounded the decimals. Okay, so these are all approximations. So 1 pound is approximately 0.454 kilograms. 1 ounce is approximately 28.35 grams, and so on. Okay, apply. Bridge engineering. The Golden Gate Bridge can hold about 35,924 pounds across its entire length of 8,981 feet. The average midsize car weighs about 1,524 kilograms. Okay. Question about how many midsize cars could travel across the Golden Gate Bridge at one time. So this right here is irrelevant, the distance. Okay, we took it further in class and determined how many cars could actually fit on that bridge at one time if they were bumper to bumper, but we're not going to go into that much detail here. All we want to do is find out how many mid-sized cars can be on that without exceeding this weight limit. So if this is in kilograms and this is in pounds, we want to convert one to the other. So if I have 1,524 kilograms, okay, and I put that over 1, and I want that to equal the ratio of kilograms to pounds, which is back here, okay, weight mass, 1 pound is 0.454 kilograms, okay, 1 pound is about 4.45. Is that 0.4? No, 0.454. Kilograms. So what we do is we take the value here and make it a fraction, but we have to make sure For some reason, this K is missing. There we go. And what we have to do is we have to put the kilogram in the opposite location as the problem that we're working. In other words, kilograms is in the numerator here. We want it in the denominator over here so they cancel. And then we're going to take 1,524 and divide it by 0.454. And I'll do that with a calculator. So 1524, 1524 divided by point, what was it? 0.454. So 1,524 divided by 0.454 is 3,350. Let's round, 3,357 pounds per car. Did I do that right? 3,357 pounds. Okay. So that is what a car weighs in pounds. So this was in kilograms, but this was in pounds. So we had to get it all in one unit of measurement. And now we have to take that 35 million and divide. So it's 35,924,000 divided by, and what did we get? 3,357, one car. And that will tell us how many cars can be on the bridge at one time. And it's 10,701. That sounds like a lot. Okay, so that's approximately correct. 10,700 cars. So that thing, what they actually did was they you always want to be able to hold a lot more than, you don't want to be close. So better to be safe than sorry. That structure will hold a lot more than what would ever be on it. Okay. So that brings us to the end of lesson 8. Thanks for watching.